Hi everybody, Captain Al speaking. Welcome to FTD PCFS number 12 brief. This is day 2 of the Dash 8 differences. A route of flight will be Seattle Tacoma to Moses Lake, KSEA to KMWH. Will be a passenger airplane. Will be coming out of gate Sierra 10. Departure runway will be 34 right. Route of flight will be direct to Olympia, Oscar Lima Mike, Victor 204 to Pascal, Papa Sierra Charlie, Victor 281 to Odessa. We pick up the clearance. The clearance will be the Harab departure to Harab, direct Olympia, flight plan route. Will be a Sonic 478 Heavy, and today will be in kilograms. So zero fuel weight will be 256.7 tons. Fuel on board 90.8 tons. Gross weight 347.5 tons. Reserves at 9 tons. Cost index 150. Cruise altitude 25,000 feet. Thrust limit will be D-rated takeoff 51 centigrade. Should arm climb 1. Flap 10 takeoff. And we'll be using NADP 1, which will be 3,000 foot acceleration height, thrust reduction 1,500, engine out acceleration height 1,000 feet, wind 020 10 knots, slope 0, the CG will be 25%. The weather at Seattle Tacoma 020 10 knots, 15 statute miles, 2,500 broken. Temperature 13, dew point 8, altimeter 299 departing 34 right. Moses Lake weather will be 29015, visibility 12 miles, 1800 scattered, temperature 23, dew point 21, altimeter 3003. RNAV GPS Yankee 32 right approaches in use, and we'll be landing 32 right. Clearance when we pick it up will be Sonic 478 Heavy, cleared to Grant County International Airport via the Harab, whatever it is, departure to Harab, direct Olympia, flight plan route. Climb maintain 4,000, expect flight level 250 10 minutes after departure. Seattle departure will be 125.9 and will squawk 4744. This will be the profile for the day 2. We'll forego the pre-flight. We did that last week. But we will be up to the point where we're going to start all 4 engines. In today's lesson, we'll have a APU that is inoperative. So we'll have the ground air carts hooked up, and we'll do a ground pneumatic start at the gate. We'll disconnect external power and external air and then push back and do a cross-bleed start on engines 3, 2, and 1. The procedure is basically the same as the 400 with some slight differences. I will taxi out to runway 34 right. I will not complete the takeoff checklist so that when we take the active runway, we'll get the checklist incomplete norm. And we also will not complete the approach checklist or the landing checklist. And then we'll show how that message comes up for each of those conditions to let us know that we need to accomplish those checklists. We'll take off runway 34 right. No low altitude level off. We'll skip that. We've done that before. Again, on departure, we'll look at the vertical situation display a little bit. Leveling at 250. We'll take a look at display management again in the form of review. We'll do a cruise climb to flight level 300. We'll get a engine failure number 2 or an engine 2 limit exceedance. I'll see what I can do there in the PMDG model. We'll do an engine in-flight start on number 2. We'll get the engine back. On the descent into Moses Lake, we'll have a hydraulic pressure system 1 problem. We'll run through that with the electronic checklist, and then we'll set up for the RNAV Yankee 3-2 right approach using IAN procedures. That will be to a go-around, and then after the missed approach, it'll be ILS 3-2 right to an auto land. and then taxiing in with the airport map display, and then shut down and securing. So you can see it's somewhat similar to the first profile, and those two periods generally are enough of the differences in order to qualify for, if you're qualified on the 400, those differences would qualify you for the differences on the Dash 8. Some airlines will add simulator periods after this. Not many, but some do. And I always thought that was a good idea, but there's not that many airlines that do that. We talked about this when we do start the engine. We will have the auto start appear above the N2, and you'll have the little green tick marks indicating the idle target indicator. And again, that's where the engine can sustain itself at idle. Once it reaches the idle target indicator, it'll go to running. Running will appear for 30 seconds and then disappear after that. In the case of an engine failure, it will attempt continuous relight, and you'll get auto relight above the N2. Again, we are going to start engine number 4 first because of the ground pneumatic start, APU being inoperative, and then we'll cross bleed start 3, 2, and 1. And we'll start one engine at a time as opposed to auto start where we started 2 engines at a time. Checklist incomplete norm, we said 3 conditions on the Dash 8 that would cause that. Before takeoff, you're aligned with the FMC runway and you have not completed the before takeoff checklist. Approach would be if you're below the FMC transition level and the flaps are not up, and you have not completed the approach checklist, you will get the checklist incomplete norm ICAS alert message, which is a caution. And then landing, if you descend below 500 feet above the FMC landing runway and you have not completed the landing checklist, you'll get the checklist incomplete norm. And again, I'm going to not complete those checklists, assuming I remember, and then we will see that message come up on all 3 situations there. Here's the HAROB. In this case, it's the 3 departure, whatever the current one is. I'm not sure what it is, but it's probably different than this. Departing 3-4 right, it would be climb direct to DOTV, then via 341 track to whirl, then via depicted route to HAROB. And the routing via transition, expect filed altitude flight level 15 nautical miles from Seattle. We'll maintain whatever the assigned altitude is. I think our initial clearances were climbing to 4,000 feet per the clearance. And on the HAROB departure, DME, IRU, or GPS required, and RNAV1 is required. And again, we can see that again on the Dash 8 right on the ND where you'll have the RNP. And we are checking that it's 1 for the departure and that the ANP is within that. Again, radar required. We read all the notes. Transition 180. Seattle departure 120.4. In the minimum sector, we're going out to the east, will be 6,400 feet. The NavRad page has 2 pages. This is a difference from the 400. On the 400, we had 1 NavRad page. On the Dash 8, we have 2 NavRad pages. On page 2, you have what's called a Nav Options page, and you can get there either from the page 2 by going to the NavRad page and then selecting Next Page, or you can also get there from the Position Reference page 3 or the Reference Nav Data page. You'll have an option to get to the Nav Option page as well. On the navigation option page, you have the Nav Aid inhibit lines. This is where you can put in a Nav Aid, and the FMC would inhibit that Nav Aid from being used for DME position updating. It would not use it. You could also put in the Nav Aid to inhibit only the VOR portion, the VOR radial portion. And this is similar to the 400. We discussed this. To inhibit an entire Nav Aid from being used, or just the radial DME portion from being used. You also have, what's unique about this is you have 4 on-off selections for DME updating, VOR radial updating, GPS updating or localizer updating. And normally all those would be on, but you could disable, for example, if you did disable the GPS updating, then it would go to DME updating. And if you turned that off, it would go to radial DME updating. If you turned that off, it would go to strictly the IRS nav only. So those are normally on, but you can disable each one of those independently if you needed to. The vertical situation display, we said you can get there by selecting the being in the map mode, and then you would normally have the expanded mode displayed on the ND. If you push the center little momentary action push button, it would go to the 360 map center mode, and then if you push it again, it'll go to the VSD mode, and the VSD would show up on the bottom third of the ND. And we did say that the VSD would show a representation of, if you were looking at your airplane almost from the right side and looking at it in terms of a vertical profile and a lateral profile, mileage going out on the x-axis and the altitude on the y-axis. And of course then you have a vertical segment that you're looking at. The vertical segment that you are looking at is what's included in the en route swath. And we did say that the en route swath, which is number 1, would not appear on takeoff until you're above 3,000 feet and more than 6 nautical miles from the runway, and then it would appear. And it would disappear when you get below 3,000 feet and within 6 nautical miles of the runway. So when that happens, it would disappear on approach, and it would appear on takeoff. Now, we said in the PMDG model, it's there all the time on takeoff. It doesn't disappear, so it's kind of wrong. Again, you can see there's the RNP for the departure that we can check that it says RNP1. And again, you're going to get the RNP, ANP, the lateral deviation. When you are on the vertical profile, you're going to see the vertical deviation indicator. And again, that's going to include an RNP and ANP as well. Here's a cross-section of the vertical situation display. You have the vertical flight path vector, which is this white line that goes out from the airplane symbol. The airplane symbol is an elongated triangle, again, as if you're looking from the right side. The range to target speed dot is that little green dot that will appear usually at 15 knots prior to your target speed, and it goes out at 5 knots from the target speed, and it kind of like a little ball along a straw, it moves along this line as you approach the target speed. If you're in vertical speed, you will get a dashed magenta line, and this will vary depending on the vertical speed that's selected. And then of course you have a terrain indication that would appear as green or amber or red depending on the terrain you're approaching or that's underneath you. And then you will have a 3-degree reference to the runway. It'll be a dashed cyan line if no approach is selected. If an approach is selected, generally it will go to a solid magenta line showing the profile for the approach. You'll also have gates at 1,000 feet and 500 feet. The 1,000-foot gate would be white, and the 500 feet gate would be amber. And this kind of correlates with what you have on your altitude indication on the PFD when you get the bars at 1,000 feet and at 500 feet. And then, of course, the runway will be displayed. Again, on the VSD, anything selected on the MCP as far as altitude will show up as a dashed magenta horizontal line. If you set baro minimums, that's going to show up as a dashed green line on the VSD. And the any altitude restrictions will also show up as triangles. If it's an at restriction, it'll be 2 triangles pointing at each other. If it's an at or above, the top triangle will be gone. If it's an at or below restriction, the bottom triangle would be gone. You'd just be left with the top triangle. Again, you can see the FMC glide path angle will be represented by a solid magenta line. And then restrictions show up as the restriction along with, if we do have a restriction at that waypoint, and as a dashed vertical line. And we saw a good representation of this with Mount Rainier, and that was that the green would represent 500 feet or more below the aircraft. Amber would represent anywhere from 500 feet below the aircraft to 2,000 above, and then more than 2,000 above, the terrain would be painted red. And so as the airplane approaches that terrain, if we were going to climb away from that terrain, the vertical flight path vector would show how we're going to be in reference to that terrain. The ICAST display select panel again would show which display we have selected as the MFD, the multifunction display. The electronic checklist is normally displayed on the lower center MFD. With an engine failure, we can also display the secondary engine instruments on the inboard display by going to left inboard or right inboard and selecting engine. And then that secondary engine display will show up on the inboard display. And that's so you can see that it's attempting a relight. To do an engine in-flight start, we can go to the non-normal menu. We can go to unenunciated checklists, and we can dig down to engines, and then we can get to engine in-flight start. Many times the checklist will lead us to the proper non-normal checklist, but there are times when we may have to dig down into tiers in order to get to the checklist we want, especially for unenunciated checklists like fuel jettison, things like that. They don't come up automatically, so we would have to go into the menu, in this case the non-normal menu, and into the unenunciated, and then to the appropriate checklist, like in this case fuel jettison. There's the auto relight. We talked about that. That'll be attempting a continuous relight when an engine does fail. Generally, the approach RNP requirements for an NDB approach would be 0.6. Again, we could check that right on the ND with the RNP. For VOR, it would be 0.5. For just an RNAV approach, 0.5. For RNAV GPS approaches in the 400, it's 0.3. In the Dash 8, it's meant to get down to 0.1. When I left, we still used 0.3. It wasn't approved for 0.1. I don't know if it's approved for 0.1 now, but it can go as low as 0.1. Here's just a representation of what the lateral RNP and ANP represents. The airplane itself has an area around it that is called the ANP circle, the actual navigation performance circle. And that's where the FMC basically will look at its navigational accuracy, and it puts you within a 95% accuracy within that circle. The RNP would be the required navigation performance for the airspace that you're in. Airplane position would be represented by the little vertical hash mark. That would be where the airplane is. And then, of course, this triangle would represent the FMC, in this case, the lateral position of the FMC, like, for example, if you're an LNAV. And in this case, the airplane position and the LNAV position would be right on. And then the RNP, you can see, would be represented by these single vertical hash marks, and that would be in reference to whatever the RNP is from your airplane center line for the airspace that you're in. And that's going to change. En route it might be 2. As you get into the approach area, it might be 1. On departure, it'll be 1. And but as you do the approach, it may be 0.3, for example, if you're doing an RNAV GPS. So you can see the circle around the airplane is 2 times the ANP, and that represents where the airplane is estimated to be 95% of the time by the FMC position. If the actual navigation performance then would be represented by the bar here, the white bar, and that would be the ANP. You can see that coming down here. The actual navigation performance is this, the white bar. And of course, this space in between here is really your maneuver space right here. The difference between the ANP and the RNP is your excess, if you want to call it that, your maneuver space. As the accuracy becomes less, these bars would tend to move in. And if they continue to move in and they touch each other, then the ANP would equal the RNP, and that would not be good, because now your accuracy would be such that you're not able to maintain the required navigation performance. So typically you're going to see them like this, where you do have the ANP, and depending on what the ANP is, the bars will be real small or a little bit bigger. But the less accurate they are, the more they'd move in. The more accurate they are, they'd move out. And again, your airplane position in reference to the lateral navigation, like in this case, if we were an LNAV, would be displayed as the difference between the triangle and your vertical line, which is where you are. Here's a representation of the, for example, the LNAV course. And if we end up left of our route, the LNAV course would show to correct to the right, and that would be represented by the magenta triangle. And again, the airplane position would be right here, and the triangle would represent the LNAV position. And in this case, you can see the airplane position is to the left of your routing. We need to correct right to get back on course. If you're right on the route, or right on the lateral profile like LNAV, the magenta would be lined up with the airplane position, which is the single vertical line, and we would be right on course. If we end up to the right of the route, then the pointer will go to the left. Again, the airplane position is right here. The pointer is the difference between the airplane position and the LNAV course. And you can see in this case we are to the right of the course, and we need to correct to the left to get back to the center line. This would represent a large FMC position uncertainty. The bars are bigger, and you can see the ANP has grown, and it's getting closer to the RNP limit. And you can see here that if we were to get to the left of the route like we are here, we need to correct right to go back to our course. But if we drift too far left and the ANP starts to infringe on the RNP, then the scale itself will turn amber, because now we're outside the RNP boundary. We aren't within it with a circle. So this scale will turn amber. And you'll notice the bars haven't changed because the ANP hasn't changed. It's just your aircraft position has changed in reference to the RNP, and we're infringing on the RNP now, so it turns amber. If we were to get a large FMC position uncertainty that continues to grow, then eventually these two bars would touch. If they touch, it'll go amber, and you'll get a nav unable RNP message, because now the RNP equals the ANP, and you don't have the required accuracy to maintain the RNP limit. Same thing happens on the vertical profile. Again, the airplane is represented by the middle white hash mark. If you happen to get above the path, the pointer will move down. And again, your position is right at the horizontal line. And you notice the desired VNAV path is below us, and that means we're high in the path. If we're right on the VNAV path, it's centered. And you can see here again, if we get low on the path, the needle, little triangular symbol will move up, representing the path. And in this case, where we are is the little white hash mark, and the path is in this case above us, and so we're below the VNAV path. Again, you can see we have the RNP in feet for the vertical path as well. And you can see in this case we're within the RNP in each one of these situations. Even though we get high on the path here, we haven't infringed on the RNP yet, so the scale is still white. But you can see if we go too high on the path and we start to infringe on this RNP, then the scale itself will turn magenta as well. So you can see here it says the vertical nav performance scale display the same relationship between the maneuver space and the A&P as the lateral navigation performance scales do. And this would show if we were to infringe on that, we get below the path, and now we cut into the RNP with our accuracy circle, the scale turns amber. And again, if the error, if the A&P grows and the two white lines touch, then the A&P will equal the RNP, and the whole scale will turn amber, and you'll get a enable RNP message as well. And you can see in this case we're right on the path, and the A&P is within the RNP, and so everything is really good here. That's what we want to see. The integrated approach navigation profile looks like this. It's very similar to an ILS approach, with the exception that when the glide path is alive, and really we use more of this when it's about 2 miles from the final approach fix. We'll go gear down flaps 20. We use that more than glide path alive, because like we said, a glide path is different than a glide slope. A glide slope is more like a fan, and it fans out, so the further you are from the runway, the wider the fan is. So the glide slope will move slow when you're pretty far out. If you're closer in, the glide slope will move faster because the fan is starting to narrow. Well, the glide path, though, is more like a tube. It's your RNP, which is going to narrow on the approach, and when that glide path is alive, it tends to move faster than a glide slope would move. So we normally will configure earlier than we would for an ILS approach. But you'll notice that the profile looks pretty much the same as an ILS approach. There's not a lot of difference. Although an IAN approach is not an ILS approach, but it has the same alerting as an ILS approach, which is the advantage. The other difference is it is not to an auto land like an ILS approach would be, where we have land 3. And again, normally we would disconnect at some point and manually land, unless we're doing Cat 2 or 3 approaches, then it would be an auto land. But in the case of an IAN approach, flare and rollout are not going to arm, and you would have to disengage the autopilot. Just like in any non-precision approach, you would have to disconnect the autopilot in accordance with regulatory requirements, and then disconnect the auto throttle for landing. This is what the IAN RNP would look like on the approach. Normally we're going to go from an approach or an en route type of RNP to a approach RNP, so it's going to narrow. And again, this is where I say this looks more like a tube than a glide slope. A glide slope would be more of a fan. The glide path is more of a tube. That happens vertically, and that also happens laterally, where the RNP may be 1, but it's going to narrow to 0.3. Here, vertically, the RNP is going to narrow as well in terms of feet. So some of the things on IAN approaches, it is a they did this primarily to be standardized on non-precision approaches. So in other words, one procedure fits all. So whether you're doing a VOR approach or an NDB approach or a RNAV GPS approach, it's one procedure. It is a non-precision approach with no auto land capability, so you have to manually land. The big advantage of this is the alerting is similar to an ILS approach. So if you get off the glide path, you're going to get alerted to the fact that you're getting off the glide path. You'll get the GPWS glide slope, glide slope, glide. It won't say glide path, but it'll say glide slope, indicating you're getting off the glide path. IAN approaches have to be selected from the database. You can't build anything with an IAN approach. You can't modify it from the final approach fix inbound. It has to be exactly as it is from the database from the FAFN. It's a QNH only approach. QFE is not allowed. You must have a published glide path angle shown on the legs page. Normally that's going to be 3 degrees, but could be different depending on the approach. All engines or engine inoperative approaches are authorized. and the RMP has to be appropriate for the approach that must be used. So again, if you're doing an RNAV GPS like we are today, we'd have to have 0.3. But again, on the Dash 8, it can go down as low as 0.1, but I'm not sure it's there yet. Raw data monitoring of the localizer is required for all localizer-based approaches. Well, we're going to have that on the PFD. You'll have the localizer displayed. FMC-based non-ILS approaches, raw data monitoring is recommended. In section C73 of the operations specifications, we'll list what type of operator you are as authorized by the FAA. And in some cases, we don't have to add MDA plus 50 feet. We can set the MDA, and that little bit of altitude that you will lose during the go-around is acceptable and approved. If you're not an authorized operator, then you have to add MDA plus 50, and that accounts for losing some altitude from a missed approach where you will not violate the MDA. In the other case, you're treating the MDA like a DA, and that's the same, that you can lose a little bit of altitude during the missed approach. Whether it's you're setting the MDA or DA depends on what type of approach that you're doing. Now, the order of preference now for non-precision approaches then in the Dash 8 would be the IAN would be the highest level. Next would be VNAV, and third would be vertical speed. So normally we're going to use IAN as long as IAN is working and acceptable. On the IAN approach, the approach push button is used to arm the either localizer or the LNAV guidance, and also to then arm the glide slope. Approach push button is also used to arm the glide path. The glide slope can be disabled, like we talked about last week on the approach reference page, or when you select the approach on the arrivals page. The glide slope can be disabled at that time so that you can get the glide path. Basically, that's what you're telling the computer, is to inhibit the glide slope so that you can make use of the FMC generated glide path on an IAN approach. These are some of the possible combinations you'll have as far as FMAs go. If it's an FMC non-localizer based approach, this would be like a VOR approach. You would have speed for auto throttle, FAC for the lateral mode, which would be final approach course, and GP for glide path. So that would be a case like a VOR approach or an NDB approach. A localizer based approach, you would have speed, localizer, and glide path. And a back course approach, you would have speed, back course, and glide path. In the case of having a localizer-based ILS approach, you'll have both ILS and FMC as the source, because the localizer is coming from the ILS, but the glide path is coming from the FMC as far as the source goes. In the case of a VOR and ADF approach, it's all FMC based, so it would say FMC for the source. Generally, the deviation scales on your PFD are going to show up when you're less than 50 nautical miles to the top of descent point, or you're less than 150 nautical miles to the missed approach point, or you're in the FMC descent phase. So whichever one of those occurs first, that's when the deviation scales pop up on your PFD. And then the IAN pointers themselves will appear when you're less than 25 nautical miles from the missed approach point, and you're within 60 degrees of the final approach course, and you're less than 6,000 feet above the landing field elevation. So all three of those have to be met. Whereas in the other case, it was any one of those three could cause the deviation scales to appear. But the IAN has to have all three of these things: 25 nautical miles from the missed approach point, within 60 degrees of the final approach course, and less than 6,000 above the field elevation. Then the pointers themselves would pop up. We can arm the approach when you're cleared for the approach. You're on an intercept leg for the approach. The IAN pointers are displayed on the PFD, And in the case of a localizer approach, it's been tuned and identified. So if all those are acceptable, then you can arm the approach when you're clear for the approach. And then at that point, the mid scales will appear on the PFD. Again, localizer based would be the diamond symbol. FMC based would be the triangle symbol. If you were to leave the autopilot engaged below the MDA or the DA, and you continue to descend with the autopilot engaged, if you get to 100 feet, you will get the no auto land ICAS message. You'll also get the no auto land on your PFD, and you'll get the caution. There is no flare or rollout armed, so you're not going to be able to auto land. And then if you continued at 50 feet RA, you would get amber lines through the roll mode and pitch mode, FAC and glide path. And so normally, again, we're going to disconnect at the MDA minus 50 feet. And then normally you have to have the runway environment in sight, just like any non-precision approach. And then you would continue manually to the runway. And then on a short, finally, you would disconnect the auto throttle. The use of the glide path below the MDA or DA can be used, but it's used for reference. So just like if we were doing a non-precision approach in the 400 and we get below the MDA and we disconnect the autopilot, the vertical deviation indicator can be used as a reference. Well, it's the same thing here. We can use if we have a glide path, we can use it, but we use it only for reference. Visual prevails, meaning that you have to see the runway environment, approach lights, runway, enough to continue down below the MDA visually, and then of course you would use the PAPI or VASI to then judge your height from the runway. So it can be used, the glide path can be used for a reference, but it's not used as a primary. Primary is what you see outside visually, and then transitioning to the PAPI or the VASI on the runway for the last segment of the approach and landing. If we have to do a missed approach using IAN procedures, if the autopilot's engaged, the auto LNAV would activate at 200 feet RA automatically. If the autopilot were not engaged, if you had disconnected the autopilot on a non-precision approach, continued down, did a missed approach, auto LNAV would activate at 50 feet RA or above. So autopilot engaged, 200 feet, you'll get auto LNAV as long as you're above 200 feet. Autopilot's not engaged and you go around, auto LNAV will activate at anywhere above 50 feet RA. And then on a go around, if the flaps are left at 5, like we showed last week, you would then have to do an item override on the electronic checklist in order to complete the after takeoff checklist. On the way into Moses Lake, we'll have a hydraulic pressure 1. That's going to be no different than what we did in the 400. It's just we're using the electronic checklist to do it. And we will have to, again, allow additional time for flap and gear extension. Again, we're going to set the speed after the flaps reach the selected position because they are slower to move. So we're going to keep our speed until they reach the selected position and then set our speed after that. On the go around, we're going to leave the gear down, and again, we're going to limit the flaps to 10 or 5 in order to not have to go through that 3 minutes and 40 seconds of extension or retraction from 5 to 1. And that completes the briefing for the FTD PC FS number 12. Day 2 period.